So I want to talk about for loops. Let's start with the geometry node. For loops in Houdini is based on for loops in coding. The concept is the same. However, if you come from a coding background, you may be completely confused with the for each loop and how you use it in Houdini. This is because it's really hard to visualize for loops, and especially when you're using nodes to represent loop iterations. Houdini's workflow is mainly based on node style environment. All the nodes in Houdini have SideFX codes behind them doing all the hard math calculations or complex calculations for us. So it's still code behind the scenes. You just don't see it. You see a node with visual UI, easy to use UI. If you come from a coding background, the for loops in visual nodes is quite different from coding for loops line by line. The syntax and workflow is quite different. On SideFX's documentation website, they have an example where they show you how to procedurally model a cheese using for loops. You can go check that out. I'll provide a link in the description below. Now I'm going to get started by dropping down a cube first. Now I'm going to apply a for loop to this box. And we have a lot of these for loops. For now, I'm just going to use for each number. So what this does, it just repeats any operations you put in here into this middle, into the orange block here. It'll repeat all those operations X number of times, X being the iterations. And like right now, it's repeating all the operations in this orange spot 10 times. It just repeats the same thing over and over and over. But there's a lot of ways you can repeat it. And we're going to explore some of the ways. So right now it's not doing anything. There's nothing inside this orange block. I'm going to put something in here. I'm going to put a transform. And I'm just going to move the box to the right twice. Now it's only moved once, but we have 10 iterations. You might be wondering what's going on. Well, let's go to the for each begin node right here. Right now, it's fetching the input. What that means, it just takes exactly what this original box, that's this position right here. It takes this as is, no changes, and feeds it in to the for loop, into this orange. Every single time, for every 10 times. It just feeds it in like that. Well, that's not going to result in anything. It only results in this box being moved over to the right once, because we're always feeding for all 10 iterations, we're always feeding the same spot. So it's like writing your name on a piece of paper and erasing it, and writing your name on a piece of paper and erasing it 10 times. You end up with just your name on the piece of paper, one name, one on that piece of paper. What if we wanted our name 10 times on the piece of paper? And in this case, we want the box moved to the right 10 times. So it would be really far over here when it's done, because it would move it twice, all the way to 10 times. And somewhere, it would be somewhere over here. We want the for loop to accumulate. So we don't want to fetch input. What we want is fetch feedback. And what this does, it takes the result of every single loop and feeds it back. So let's put the render flag here. So now we have the first iteration. This is the first time the for loop goes through. Now this is 0. This is once. This is the first loop the for loop goes through. This is the second time. The third time, the fourth, fifth, sixth, 7, 8, 9, 10. This is 10 loops. Every single time the cube gets further and further to the right, because this transform node moves it further to the right. Now you might be asking, why do we have 10 boxes? That is because when you click this for each end, there's a gather method. Merge each iteration. Now what this does, it takes the result of every single loop and makes a copy of it and merges it with the next one. Now let's just put it to feedback each iteration. So this does not do anything special at the end. It just mainly just repeats it 10 times. That's all it does. Nothing special, no merging, no nothing. So let's try that first. Now we have the box moved over 10 times to the right. Let's take a look. This is the first time it's moved over once, twice, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 times. Now, if we merge each iteration like this, we have 10 copies of it. I'm going to show you what merge each iteration looks like. Let's turn it back to feedback each iteration. So this is just plain for loop 10 times, nothing special. But if we put a merge here, so I take each iteration at the beginning and I merge it with whatever I transform. So first, okay, let's here, right here. Let's turn this back to one iteration first. When the box comes in, it starts here. We enter the for loop. We move it to the right once. But we take the original one and we merge it with the one that we moved to the right. So we merge these two together. That's one iteration. Now we're going to do the second iteration. Second iteration. Here. This result. This is the results of the first iteration. It gets feeded back in up here because we have fetch feedback. Then we move it over to the right. Both of them, both cubes. The whole result gets moved over to the right. And we have this. This is merged with this. We end up with this. There's actually 4 cubes there. There you go. The middle one is laid on top of it because the results of the first loop was 2 cubes and we moved the entire 2 cubes over to the right. And we also merge it with whatever it had at the beginning, which is the 2 cubes. So the middle one is overlapping. But what I wanted to point out is this kind of setup, putting a merge down here, merging it with the input of the iteration is exactly as what you have here. Merge each iteration. That's what that does. It's merge each iteration is exactly the feedback each iteration plus a merge at the end. So if we take this out, if we take the merge out, change it back to merge each iteration. Oh, we don't get the first cube. That's actually the only thing that's different. We merge the results of the for loop. So the result of because the first loop, you need a chance for it to go through, to run through it first. When we had this, this merges it right away with the input before it even finishes. So let's turn this back to 1. So this is the one here. The first iteration, it already has an input and it's merging the input already. This input and this and the cube that's moved over, it merges both of them together. However, when we do, if I delete this and I do a merge each iteration, it merges the results of the for loop. It does not merge the first input, the very first time it goes through this first one, this original box. It does not merge this one in. It merges the result. So it has to go through the loop once and then merge together. So I get that's That's the only difference that I can see with the merge each iteration and the feedback each iteration, plus a merge. So if you wanted to do your own merge each iteration, you can. You just turn it into a feedback and just add a merge at the end. It will be slightly different from compared to this one, and the only difference is the first time it goes through, you'll have the extra first initial input, the box initial input. So that's the only difference. Now, I also wanted to explore. Now, if we have just fetch input just gets the original box as is, and it applies whatever operations you have in the middle here. What that does, that's where it gets a little interesting. So I'm going to take this box here. I'm going to scatter some points onto it. We don't need that many points. Maybe 10 on this box. And let's say I'm going to put a spear. I'm going to make a very small spear though. Okay. That's the spear. And copy 2 points. Copy this spear onto the points. So it's all over the cube. Now I'm going to take these points. I'm going to subtract it. So we're left off with this. Like the Swiss cheese example in the SideFX documentation. So you take that and you poke holes through it. Well, that's cool, but I want to keep doing it. I want to repeatedly take this box and repeatedly poke more holes into it. So I want to do this again. I'm going to take this, copy it, paste it. Sorry. Okay, I'm just going to make more room first. I'm going to put a box around this. So this is the first iteration. First iteration. The second iteration. Now I'm going to take the result. Call this result 1. I'm going to take this result 1. And I'm going to feed it into the second iteration. Because we want to take this this cube with holes in it, and we want to poke more holes in it. So we get something interesting. So we take the result of this, scatter points on top of the cube that already has holes, copy more spears to it, and take the result of this and feed it into this. So let's move this over a bit. And we have more holes. Now imagine what this would look like if we keep doing this repeatedly, like over and over and over. Well, I don't want to keep copying and pasting this like over and over and over. It's gonna be long and it's not clean. So that's where for loops come in. Now I'm gonna delete this and I'm gonna start a new one because I'm gonna share this file later. So I want you to be able to do this, recreate this. So we don't need this. And let's add a for loop. Let's go for each number. Now let's put this operation inside the orange block, because we want to repeat this hole poking operation over and over and over. Now the input is this for each is my input, and I'm going to put it into the scatter because I want to take this box and I want to scatter points on top of it. Now this is where the object where I want to poke holes out of, which would be the input again. The results obviously goes over here. This doesn't look like there's a lot of holes. And that's because right now we have fetch input again. So it's plainly just getting this box as is, and it's only poking it once. We want to accumulate. We want the for loop to accumulate. We want to get the previous iteration and poke more holes onto it, and then more and more and more. So we're going to fetch feedback. Now we're starting to see something. Now it's not making any sense because I think it's because it's merge each iteration. I don't want to merge it. I just want to take the feedback and I only want to apply more holes. I don't want to end up with 10 cubes as you saw before. I just want that one cube with a lot of holes. So I want feedback each iteration. There we go. So we have a lot of holes in here now. Now let's take a look. Let's do it once. This is the first iteration of holes. Second, third, fourth, fifth, sixth, and 10. There's a lot of holes. This is the Swiss cheese example, I believe, that they had in the SideFX documentation. Now you need to be aware that when you're doing something like this, now we only have 10 iterations right now, which is fine, but let me show you something. The first iteration, the points, we have 312 points, so this is the first iteration. I'm gonna put this over here. I'm gonna change this. Second iteration. Well, that was 312 for the first one. Now it's 593 with more holes. So I'm going to change this again. Sorry, I should just lock in and check it automatically then. Now this is the third iteration. And we have 940. For 1,267 points. And it goes on and it grows exponentially. Once we get to the 10 iterations, it has 3,194 points, which is fine. My computer can handle this. But I find that if you're doing like 1,000 iterations, if I wanted to do a disintegration or dissolving scene where the cube slowly gets eaten away, I would want higher resolution because the current holes being punched out of the cube is quite rough. The circles are so obvious. You can even see the flat primitives being cut out of the cube, which is really rough. This spear, I would make it like 001, like super tiny, and have it get eaten really, really slowly. So right now, it's these little dots, and I would increase the scatter to like 100 or something, and have it slowly get eaten away. Well, that results in a lot of polygons, and this gets way out of control. The polygon count goes like insane, and even before the simulation, like before the animation is complete, my computer ran out of RAM way before it got finished off, and the boolean just goes nuts. It just doesn't work. So right after every iteration, I would suggest to do a remesh or a poly extrude and lower the count of the resulting geometry. That way it would make it a lot easier to manage. I'm gonna explore the fetch piece or point gather method for this for loop. Let's just change it. Sorry, let's change it back right here. So we have one box right now that's being feeded into this for loop. And then this box is then, the holes are being punched into this box over and over and over 10 times. But say, instead of this one box, I have more than one box. So I'm going to put a copy and transform. Copy and transform. I'm going to put this note down. So I have more than one box. Say I have 10 boxes. And I'm going to move them over by 2 again. I have 10 boxes spread out. Now I want to poke holes in each of the 10 boxes, but I want to scatter the points around each individual box. So basically I want the for loop to go through each box one at a time and apply this operation, this boolean operation that I have here. But I want to do it one box at a time. So basically I'm scattering 10 points and I have spears all over the box, but I want to scatter these 10 points on each of these boxes. So I end up with 100 spears punching holes through each of the 10 boxes. 10 spears, 10 holes per box. 100 spheres total, 10 boxes. What this does, how can we achieve this, is that in the for loop begin, instead of fetch feedback, I'm going to change it to fetch piece or point. But before that, you would need to put down a connectivity node. So what this does, it basically finds each geometry that is connected with each other. For example, this box right here and all the points within this box, that's one connectivity. That's considered one group. So let's connect this and I'll show you. Basically, this connectivity node, let me make this bigger. This connectivity node, it will group all the points within a class name, and it'll group them. For example, if I open the geometry spreadsheet, now under here I see a bunch of classes. I see 0, 1, 2, 3, 4, 5, and it all goes way to 9. Obviously, you're probably gonna see what you probably see what I mean already, but I'm gonna delete some of these. So I'm deleting everything that the class attribute does not have 0. So I'm just leaving the one that is 0. This is the one that is 1. So 2. So that's what this connectivity node does. It groups each individual 10 boxes and assigns a class attribute here, giving them this box will have class attribute value of 1, 0, and then class attribute value of 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it's 0 based. So we start with 0. So we can see it here. 0, and let me template this. 0, 1, 2, 3, 4. You get the idea. And it all goes all the way to the rest of the boxes. This groups it. Now we can use this. We can use this class attribute inside the for loop. We can tell the for loop, I want to, instead of counting from 0, 1 to 10, as what we specified here, we specify the iterations here. Instead of doing that, I want it to loop over each cube instead. And that's where gather method, okay, for each end node here, iteration method, we choose by pieces or points. Gather method, well, just leave it there for now. And it says piece elements. Now it's points because our class attribute is in the points category. So here, if you remember correctly, this connectivity is a class. The attribute name is class. So piece attribute, it's asking for that. We put class down. Oh, so we put class down here. And here we go, instead of fetch feedback, I'm going to fetch piece or point. And let's go back down here. Piece block path. Basically, it's asking us where is this connectivity hooked up to. Now, it's obvious that this connectivity is hooked up to the for each begin 1 node. So let's come back here. That's what this is asking for. So this for each begin 1. For each begin 1. It's hooked up. It's already hooked up correctly. However, if you connected it to, you can have multiple inputs. If you connected this to something else, then this will be what the respective node. So in the for each end node, we have iteration method. We have by pieces or points. Now I'm going to change this connectivity to primitive, and I don't want points. I want primitives. So the class is going to be in the primitive section. Here for each end one, I'm going to put, instead of points, primitives. So we're starting to see it. We see the last cube. Now, why am I not seeing the rest of the cubes? That's because for the gather method, I have feedback each iteration selected. I want to merge each cube. So now we see it. Now the for loop is going through each cube, each of these cubes, and it's applying this operation, this hole punching operation on each cube. So the for loop is going through the cubes. Now this is still 10 iterations because you can see piece 9, gather 10. So I'm going to show you, if I increase the number of cubes, this for loop will increase the iterations automatically. So let's do 11, 12. So it's automatically increasing. You can see here that this number is increasing. I'm not sure why the gather method is, this gather number is not increasing. It should increase with it. There you go. It just needed to update. Okay. So this is how you use the fetch piece or point. I was trying to group the boxes using the connectivity by points, but I couldn't get it to work. I could only get the for loop to loop over each cube if the connectivity was grouping it by primitives. No, it has to be by primitives. This has to be by using primitives. And you have to have fetch piece or point, and then merge each iteration. So that's how you use the fetch piece or point. In the next upcoming videos, I take these concepts and create a scene where a cube is slowly being melted or eaten away simply by using Foreach loops and a SOP solver. The SOP solver will be covered in upcoming videos as well. I then take that melted cube scene and further change the setup to create a whole new animation scene for demo on growth, where instead of the cube being melted away, strands of strings formed by the spears grows out of the cube. Please stay tuned for upcoming videos. Thank you for watching and sticking to the end.